Try to solve another Leetcode problem. 92, reverse linked list 2. So we are given the head of a singularly linked list and two integers left and right, where left is less than or equal to right. So we're going to reverse the nodes of the list from the position left to the right and return the reversed list. I think the question is quite clear. So we just need to reverse from the left to the right. So the left equals to 2 and the right equals to 4. We just need to reverse those areas, and after that it will be connected like 1 to 4, 3, 2, and to 5. So this is what reversed after the operation. So we just need to remove these areas. So let's just check the examples and the description. So this is the head and the left and the right. So this is left equal to 2 and right equal to 4. So we just need to reverse from 2 to 4. And also for the second example, we just need to reverse this 5 because it is only one node. So we're gonna reverse by itself. So the number of nodes is n is 500. It is okay. Left is less than or equal to right, and we need to write in one pass. Normally we can write it in two paths. So for example, we just need to put it inside an array, and inside an array we just need to take the positions from 2 to 4 and reverse it. We're gonna connect it as an array, and then we're gonna loop through as a linked list. But as this method, it used at least 2 or 3 loops, but we need to use only one path. So this is why we can use a linked list to solve the problem only in one path. So we're going to first start from the left. So from the left side, as left equal to 2. Normally for the reverse linked list problem, we always prepare a dummy node. Because we don't know, maybe the first node will also be reversed. So this is very helpful to prepare a dummy node. So this dummy node is going to be imported to 1. And then we're going to check the left. Before we reverse from 2 to 4, we need to know where is the previous position before the first position 2, before the left side. So we need to know the position of this one. And how can we know this position? And we can use this left. As left equal to 2. So we can use a for loop. So for I in range left, we can loop through it from the dummy node to 1. But as left equals to 2, so this means we're gonna use the left minus 1. So for I in range left minus 1, we're gonna find a pointer, which is p, gonna be ported to 1. So this is the previous position before the left. Now, if we know the previous position, and according to the previous position, we're gonna prepare the pointers for the reverse linked list. So this pointer we're gonna define it as prev, and the 2, not 2, we're gonna define it as current. So after that, how many reverse we're gonna need? So this is 1, 2. We're gonna turn it to 2, 1, 3, 2, and 4, 3. So this means we're gonna need 3 loops. So if we need 3 loops, it's gonna be the right minus the left. It is 2. It's gonna plus 1. So after 3 loops of reverse, this gonna be the previous, and this node 5 gonna be the current. So we just need to connect them together. As we already know all the positions, this is a pointer p, and this is a prev, and this is current, and we just need to connect them together. And in between, it has already become 4, 3, 2. And we just need to connect them together. So for this one, so p dot next. So p dot so this is a p. So p dot next gonna equal to the current, because p dot next gonna be the not 2. So not 2 dot next gonna equal to 5. So p dot next gonna connect it to current. So from here we're gonna use p dot next it's gonna equal to the current. And prev dot next gonna equal to p dot prev dot next. So currently this node 2 connected to node 5. Now what we need to do, we want to let this node 1 connected to node 4. So p dot next gonna equal to the prev. So this is the prev. So 1.next, so we're gonna connect it to 4. Yeah, so this is all the operations what we need. So p.next gonna equal to 4. And after that, we just need to return dummy.next, and we get the final answer. Now let me write it. So while I'm writing it, I'm gonna also explain a little bit about it. Yeah, because for linked list, reverse, insertion, deletion, it is just about connect the nodes. We disconnect the nodes and connect the nodes operations, and we need to make the drawing. Now let me just prepare the dummy node and pointer p. It's gonna be equal to the list node, and the next gonna equal to the head. Yeah, because the dummy node and p node will be ported to head. And now we're gonna loop through it. So for underscore in range left -1, we're gonna update the pointer p gonna equal to p.next. Now we have the position of p, and we can start the reversion. So we're gonna prepare the prev and current, and gonna be equal to none, and the current gonna be equal to p.next. So the current gonna be starting from node 2, and because we want to reverse node 2 first, 2 gonna be ported to none, and 3 gonna be ported to 2, and 4 gonna be ported to 3. So this is why the prev gonna equal to none, and current gonna be equal to p.next. It's gonna be node 2, and then we can start the reverse operation. So how can we start that? We need to use another for loop. So for anything in range, because we have the right and the left pointer, we gonna need, in this example, we're gonna need 3 reverse. It's gonna be right minus left plus 1. And we can start the reversion. First of all, we're gonna prepare the next. It's gonna be the current.next. And then the current.next gonna equal to the prev. And then we're gonna update the prev and the current. So it's gonna be the current and next. So after the reversion, we just needed to connect them together. This is what I don't have the drawing, but maybe let me just draw again. It's gonna be 4, 3, this gonna be 3, and this gonna be 2, and we just needed to connect them together. So as I said before, this position 4, actually for this node 4, it's gonna be the prev, and this node 5 gonna be the current. Yeah, as I said before, p.next it is node 2, so 2 gonna connect node 5, so p.next gonna equal to the current. And 2 has already connected to 5, so 1 just needed to connect to 4, so the p.next gonna equal to prev. Gonna equal to prev. So finally, we just need to return dummy.next. So this is gonna be the entire solution. And now let me just run it to check. As you can see, it works. Now let me just submit it. As you can see, it passed all testing cases, and it's pretty fast because the time complexity is O(n) and the space complexity is O1 because it is just one pass. Thank you for watching. See you next time.